Okay, so in order to have a good properties of the concrete, the first thing that we mention or we need to take care or ask is what is the water to cement ratio of the concrete that reflect its compressive strength and its durability or quality behavior of the concrete. Okay, in order to have a very good compressive strength, a very high compressive strength of concrete, we need to minimize the water cement ratio, but still we have workability problem. Yes, we might achieve a high compressive strength as a result of water cement ratio, low water cement ratio, but we still have a problem with the workability. And when we have problem with the workability, we will not get to our high compressive strength. So what we need to do, we need to put the admixtures, especially chemical admixtures. And the chemical admixture that we use in order to improve the workability with the same water to cement ratio, we use super plasticizer. So super plasticizer is a chemical that can be added to the concrete in a small dosage in order to improve the workability by at the same time maintaining the same water to cement ratio. Maintain the low water to cement ratio in the concrete. So we can have low water cement ratio to achieve high compressive strength. At the same time, we have super plasticizer to achieve a good workable concrete. The other thing that we need to uh, study for the high strength concrete is the admixtures, the mineral admixtures. So mineral admixtures is a byproducts and waste material that can be added to the concrete as a cement replacement. It's not addition to the concrete. It's not like the chemical admixtures. The chemical admixture is used in the concrete by addition. We add small dosage to the mix, but here, the mineral admixtures, when we need to use it, it can be used as a cement replacement at different replacement level, ranging between 5, it can go up to 30% from the cement by weight normally. And these mineral admixtures achieve the high compressive strength of concrete, can improve the compressive strength furthermore. So, how the mineral admixtures can contribute to the strength of concrete. The mineral admixtures contribute to the strength of concrete with two ways. The first one with the chemical reaction. Most of the mineral admixtures, or all of them, they must have high amount of silica. This silica will start to react with the calcium hydroxide that has no benefit to the concrete, which is occupy 25% of the total volume inside the concrete as a result of the hydration reaction. So after the hydration reaction, we can get calcium silica hydrate, which is the source of the strength in the concrete, and the higher calcium silica hydrate is the higher strength of concrete. As a result of the hydration reaction, we can get also calcium hydroxide, which occupy 25% of the total or the outcome of the reaction. So calcium hydroxide has no benefit to the concrete. So we have 25% volume inside the concrete of calcium hydroxide that has no benefit, doesn't contribute to that strength. So we use these mineral admixtures that contains high amount of silica. This silica will react with the calcium hydroxide that has no benefit to the concrete and convert it to calcium silica hydrate. And calcium silica hydrate, as I mentioned, it is the source of the strength. The higher calcium content, calcium silica hydrate contents is the higher strength of concrete. So we have here calcium silica hydrate. It gives a required strength at 28 days. And we convert the calcium hydroxide to extra calcium silica hydrate. So we increase the calcium silica hydrate contents in the concrete, and thus we increase the total strength of concrete. So this is also one of the methods to design a concrete with, or to achieve high strength concrete by using the mineral admixtures. The other contribution from the calcium, from the mineral admixtures, the other contribution to the strength is by backing. You know that, for example, the silica fume, the particle size of the silica fume, the particle size of the average particle size of silica fume is 100 times smaller than the particle size of the cement. So the particle size of cement here, the particle size of the silica fume is 100 times smaller. It means if we are mixing together, we can have a good backing properties. The concrete will be more dense, less porous, and the small particles here will start to fit into the small spaces here, and also minimize the voids inside the concrete. So this will also contribute to the strength of the concrete, in addition to the consuming the calcium hydroxide in the as a result from the hydration. Okay, we already discussed the advantages and disadvantages, the properties, as we mentioned before, the failure of the concrete. It can fail as an outcome from three scenarios. The first one, that the crack will go through the cement paste, or the crack can go through the particle itself, or can go through the particle, the aggregate particle, and the cement paste bond or transition zone. It can also go from there. So we have three scenarios of the concrete failure, and the concrete fail at start from the weakness point in the concrete, and since we have three parts, so the weakness part, the crack can go through the weakness part, and if any of them fail, the whole concrete will fail. So cement, it can go through the cement paste, or from the matrix, or through the aggregate. If the aggregate is weak, then the crack will go through the aggregate particle, break it into two pieces, and move. And then the whole concrete will fail. Or if the cement paste is good and the aggregate is strong, but the aggregate and the cement paste bond is weak, the bond between the aggregate and the cement paste is weak, so the crack will go through this path, which is the weakness point. So here you need to know how to improve. So what we need to do, we need to improve the three parts in the concrete. We need to make sure that we have a good paste property, we have good aggregate properties, and we have also good transition zone, or good bond between the particles, aggregate particles, and the cement paste, in order to avoid the failure of the concrete, or avoid any weakness point inside the concrete. And we already discussed here, you need to know how to improve each part, what are the factors that affect each part, and how to improve it. We move to the high performance concretes. High performance concrete is related to the durability of the concrete. We move to the self-compacting concrete, lightweight concrete, the method to produce lightweight concrete. We have actually three methods in order to produce lightweight concrete, and the definition of lightweight concrete or what is lightweight concrete is a concrete has low density, is related to its density, kilogram per cubic meters, and we define the lightweight concrete from its density. And as I said here, that the structural or ACI, the American standard, define the lightweight concrete that is a concrete has a density of 1,850 kilogram per cubic meter. So this is the density, the point that differentiate between the normal and the lightweight concrete. The lower density than this value, we can call it lightweight concrete. The higher will be the normal weight concrete. And how to produce lightweight concrete with low density. The lighter the concrete, it can be produced using three methods. Either by using lightweight aggregates, high porous aggregate. This is the aggregate that can we use in the concrete. And we have said before that aggregates is occupied almost 75% of the total weight inside the concrete. Like the total weight of the concrete, 75% coming as a weight of the aggregate. So if we do small change or small change to the aggregate, it will make significant change to the total concrete because majority of the concrete is aggregate. So if we slightly reduce the density of the aggregate used, it will significantly change, significantly be obvious in the total concrete. It's not like the cement or the water. Aggregate is 75% of the total volume and also the total weight of the concrete. So the first method is using lightweight aggregate, and we have so many types of lightweight aggregate, and they are all shared, have the same common that they must have so much voids inside that makes this stone or this aggregate lighter than the normal weight aggregate. So the existence of these voids inside the particles will make it lighter. So the lighter aggregate will result to a lighter concrete. But you need to know that as a result of all these voids, it makes the particle weaker. Then it will result to lower strength of concrete. Yes, we can get lighter weight concrete, but at the same time, lower strength concrete. And if you look, you will find that the relationship between the density and the strength of concrete, the lower density is the lower strength of concrete. Why? Simply because as a result of these voids, the existence of these voids. So the first method by producing lightweight using of lightweight aggregate in the concrete. The second one by using or by not using fine aggregate. We don't use sand in the mix. The normal concrete is cement, water, aggregate. Aggregate can be fine aggregate and also coarse aggregate, sand and gravel or big stone. So we don't use sand at all. We only use cement, water, and coarse aggregate. So we eliminate the weight of the sand. So this is also one of the methods to produce lightweight concrete. The third one by creating voids inside the paste itself. We call it cellar concrete. So we have three methods to produce lightweight concrete. Make concrete more lighter. This is the no fine aggregate. This is, and in other words, they call it pervious concrete. Pervious concrete. So this is a concrete that has no sand inside concrete. This is sealer concrete. We create voids inside the cement base of the matrix. So simply the more voids inside the mixtures is the lighter concrete, but at the same time is the lower strength. And you need to make sure that when you design lightweight concrete, you need to make sure that the compressive strength should not be lower than 17 megapascal if you want to use it for the structural purpose. So structural purpose, we cannot use any concrete that has a compressive strength lower than 17 megapascal to be used in this structural purpose in this structure. But normally the lightweight concrete, it's very much difficult to get proper strength at the same time lower value of density or lighter concrete, but they can benefit from the lightweight concrete by using it in the non-structural elements like walls or any partitions, any application which is non-structural elements, in order to reduce the dead load of the structures. And what are the advantages of using? Why we need to use the lightweight concrete? What is the advantages of using lightweight concrete? The advantage is actually it reduces the dead load because the weight is lower than the normal weight concrete. It reduces the size of the foundation as a result of reduction in the dead load. The formwork easier. It has a good actually isolation properties, good thermal isolation, and also good sound isolation, and the workability is high. The disadvantages quite would be high water absorption, so it means it's not durable, and it's required high cement contents. And here is the application. Where do we normally use lightweight concrete? So we need to start with the fiber reinforced concrete. This is another type of concrete that we might use in the industry. So what is fiber reinforced concrete? Fiber reinforced concrete is a concrete, it is simply normal concrete with the addition of fiber reinforced fiber. So concrete containing cement water aggregates and discontinuous uniformly and distributed fiber. So it is generally normal concrete, but we add fiber, discontinuous fiber, the ununiformly distributed, like here, it just randomly distributed in the mix. This is what it means, like ununiformly distributed in the concrete. So after we have this one, normal concrete with fiber, we start call it fiber reinforced concrete. So it's a composite obtained by adding a single type of fiber to the or blended types of fiber in a conventional or in the normal concrete mix. So fiber reinforced concrete is a concrete containing fibrous material which increase its structural integrity. And we'll get to know what is the purpose of this one. Fiber can be in the form of steel fiber, in a steel form, a glass fiber, natural fiber, synthetic fiber, and we have other types of fiber that can be used inside the mix. It contains short, discrete fiber that are uniformly distributed and randomly oriented inside the mix. So fiber, it can be used in the concrete if we have fine and coarse aggregate, the normal concrete, or it can be used also in the cement mortar, which is cement, water, and sand, and we add fibers. even if we don't have coarse aggregate in the mix, or even if we just add it when we have like a little without or a little amount of sand. So fibers can be used in different ways with the concrete, with the mortar, or with the paste, or mortar with a small amount of sand. What is the purpose? Why do we need to use fiber inside the concrete? Actually, the main purpose of the fibers on the concrete is to increase its tension properties. And you know the stress strain diagram and the failure behavior of the concrete is brittle. Actually, it's different. It's not the concrete is not ductile material. It doesn't show any deformation before it fails, like the steels or any other material that shows uh, deformation, plasticity before it failed. It's simply brittle material. It failed directly, sudden failure. When we have a concrete, the concrete fail. When you apply the load on the concrete, then the concrete fail directly. We call it brittle material, like glasses. How the glasses break, it's break without any indication of deformation or any plasticity. There is no sign that shows that there is failure is coming, failure is coming. No, we have sudden failure, brittle failure. If we take a steel, the steel will have, it shows some deformation. We have changing in the length of the steels, and we can see that failure is coming, and until it reaches to the friction point and the material fail. This is the behavior of the ductile material. So in the structure, we try to uh, have a material, use a material with ductility behavior. We try to avoid any material that has a sudden brittle material. So it would be better to use concrete that has a ductility or deformation behavior. So as I said, concrete is a brittle. In order to improve its behavior, failure behavior, to make it more ductile material, we use steel fiber. So steel fiber, this is the plain concrete that has no fibers inside, and this is the other two mixes that contains with a wide, either low or high amount of fiber. So the high fiber content is the more ductile material, the more plasticity the material. So this is how it break without fiber, brittle, and this is with fiber. It can show some resistance when there is fiber inside. Before it, this one we call it plasticity, deformation of the material. So the purpose of fiber reinforced concrete, it increase the tensile strength by delaying the growth of crack, delaying the growth, the creating of the crack, improve the impact strength and fatigue strength, reduce crack with width and control the crack with tightly, thus improve the durability of the concrete. And you can see here, this is a mix. This is definitely not normal concrete, not plain concrete. The concrete doesn't have all these deformation, all this plasticity. When you go to the lab and you use one prism of the concrete will suddenly break, brittle. When you start applying the load, and at some point here, break the concrete fill into two pieces without showing any deformation like this one. But this is after we use the fiber inside the mix. When we start using the fiber, we start to see these deformation, these ductility behavior of the concrete. So this is good, and it's better than the concrete that has brittle behavior. So what is the purpose? Improve the impact, improve free throw resistance, and we have so many. It also can contribute to the reduction in the shrinkage of the concrete. The types of fiber, we have different types of fiber that can be used inside the concrete, starting with metallic like steel, stainless steel fibers, and the most common fiber that can be used. And we have synthetic fiber like nylon, carbon, polyester, and all these type that can be used in the concrete. We have mineral fiber like glass fiber, and we also can use fiber from the natural fiber from the jute, core, bamboo, coconuts sometimes. So these are actually examples of different types of fiber that can be used inside the concrete. And again, as we mentioned before, the mineral admixtures, we have, for example, different mineral admixtures. We have fly ash, silica fume, methacholine, rice husk ash, etc. All of them, yes, they are mineral admixtures and they contribute to the strength, but the contribution to the strength is different from one type to another. The behavior or the impact of using silica fume is totally different than the use of fly ash. In silica fume, silica fume is the most effective mineral admixtures and can be used up to 15, maximum 20%, and it can significantly improve the strength, in which fly ash, if we use 50 or 20%, will not contribute or reach to the same strength that silica fume can achieve at the same percentage replacement. So different mineral admixtures, different behavior, different contribution to the strength, different type of fibers, different behavior, different contribution to the tension, to the workability, to the concrete properties in general. So these are the pictures of example of fibers that can be used in the concrete: steel fibers, glass fibers, we have carbon fibers, nylon fibers, natural fibers. Starting with the metallic fibers here, even the metallic fibers come in different shapes, in different thickness. Some come in rounded shapes, come in rectangular, and different length of the particles itself. So steel fiber, it gives high structural strength, aspect ratio between 30 to 20 to 150. So what is aspect ratio? Aspect ratio, as I said, the length of the fiber itself. It also, with the same material, steel fiber, the length will affect differently. The higher, the higher, the longest fiber will be different than the shorter fibers. So aspect ratio is the length divided the length of the fiber so aspect ratio we can define as is the length of the fiber itself divided by the diameter. So aspect ratio of the fiber used in the concrete, it can be defined as its length, the length of the fiber, divided by its diameter when we use it rounded, the diameter of the fiber. And the ratio it can be in this range. So we have different length of the fibers at different diameters. So it will also give different effect on the concrete properties in terms of the workability, the strength, the tension properties, and etc. It also improves the impact and abrasion resistance. We have rounded steel fiber and rectangular steel fiber. This is the rounded steel fiber and this is the rectangular steel fiber with specific thickness, range in thickness, range in the length of the fiber itself. And again, the change of the length of the fiber will make change of its effect on the concrete properties. Used in precast and structural application, it can be used in the highway, airport pavement, etc. Here is where do we use the fiber reinforced concrete, and this is what we have discussed also. But here, the tensile load with the deformation, the plain fiber, it can suddenly fail, but when the concrete has a little bit fibers, it can make more ductility inside the concrete. So how to use fiber in the concrete? It just simply added the fibers in the fresh mix of concrete. How to use it? It just simply added the fiber in the fresh mix of the concrete and mix it with the normal concrete ingredient or material. So fiber reinforced concrete improve the structural strength, but this is in general steel fiber, but not all the types of fiber can improve the strength, especially compressive strength. Reduce steel reinforcing requirements, because the steel bars or the reinforcing bars, the purpose of the reinforcing bar is to resist the tension force, and since we add this one, then this can consume or it can handle some of the tension strength. It's improve the ductility of the failure. It's convert the concrete from brittle behavior to a ductile behavior. Reduce cracks. It can improve the abrasion resistance and also improve the freeze-thaw resistance. Factors affecting the workability of, and also the not only the workability, it can also the general properties of the concrete. The first one and the most important one is the aspect ratio, which is the length of the what we call it, the particle length or the fiber length divided by its diameter, and also the volume of the fiber inside the mix. And the maximum volume is 2%. The maximum volume to be used in the concrete, 2% of the total volume. Let's write it here. Maximum 2%. So 2% volume steel fiber is the maximum. Why? As we mentioned before, the higher contents of fiber is the higher tension properties. It is the higher ductile material. So why we need to limit it up to 2%? Because it's especially for the steel fibers, it's will start negatively affect the workability, because the more volume, the higher volume of the steel fiber is the lower concrete, it makes the concrete more stiff, harsh, difficult to mix, difficult to handle, difficult to transport. So that's why they put, or it's not recommended to use fiber more than 2% of the total volume of concrete. What other factors that affect the concrete properties is the also the size of the fiber, also the specific fiber surface. The surface of the fiber itself can also affect the durability, the workability of the concrete. Here is also kind of fibers, the glass fiber, high tensile strength, and this is some information about this kind or this type of fiber. But normally, not all the fiber can improve the compressive strength of concrete, but they are all contribute to the tensile properties. Because the use of this one in the mix, glass fiber or nylon fiber, it can also be either not affecting the strength or reduce the compressive strength. It can be either reduce or not affect the compressive strength of concrete, but all of them will contribute to the tensile properties in the concrete. Synthetic fiber is man-made fiber. This is what I mean by synthetic fiber. Like it's produced in the factory. And this is the nylon, polyester, and etc. This is the types of fiber that can be categorized under the synthetics type of fibers, and it's high chemical resistance, low modulus of elasticity, cheap and abundantly available. You can find it easily, this kind of fibers. It also have advantages. It can improve the tear and froze, makes the concrete cohesive, and improve the pumpability. So you can see here the effect of this one on the workability is better than the effect of the steel fibers, the effect of the steel fibers on the workability. So different types of fibers will give different effect on the concrete properties in general in terms of the workability, the strength, and etc. Natural fiber is the fiber that be taken from the natural, like the bamboo, coconuts, etc. This is also types of fiber that can contribute into tensile properties of the concrete. Okay, so what is the effect of these types of fiber on the mechanical properties and also to the strength of concrete? In terms of the strength of concrete, it can be either not contribute or slightly contribute to the strength of concrete. So it's the value, the improvement, it can be either not contribute or slightly contribute to the strength of concrete. Modulus of elasticity, it can be seen that also there is slightly improvement. It can go up to 3% to the contribution of the modulus of elasticity for the concrete, in which flexure strength can be also increased up to 4% when we are using fibers in the mix. The same contribution for the splitting tensile of the concrete. Factors affecting the properties, we already discussed this one. The volume of the fiber, the aspect ratio, the orientation of the fiber. We cannot just simply add the fiber in a good arrangement. No, it should be randomly or ununiform distributed inside the mix. The volume of the fibers, the maximum, as I said, is 2% for steel fibers. So there is a range for each type of fiber, and based on what is recommended from either previous studies or from the standards. And for the steel fibers, the maximum is 2%, ranging between 0.4 to up to 2%. The the nylon and the other synthetics fiber, the maximum is 0.5%, were based on the uh, uh, its behavior or properties of on the effect on the concrete properties. So what makes the steel fibers different than the normal fibers? In terms of the, for example, the durability, the fiber reinforced concrete is higher durable if we need to compare it with the normal uh, concrete, like with and without fibers. The concrete with fiber is will show high durable compared to the concrete that has no fibers. The concrete that has fiber, it can protect steel from corrosion, can protect the water from penetrate and steel reach to the steel. But here there is a potential for the steel to corrode. Steel fibers is slightly more expensive. The production of the fiber reinforced concrete will be more expensive than the production of the normal fiber or normal concrete, because here we need to, because simply fiber reinforced concrete is normal concrete with the addition of the steel fibers. So it's originally normal concrete, but I add extra material, which is fibers. And as a result of the addition of these fibers, especially steel fibers, you need to pay the extra cost of the steel fibers. Also, we know that steel fibers reduce the workability, so I need to use super plasticizer, the chemical admixtures, in order to re-improve the workability of the concretes. And this will be more expensive if we compare it to the normal concrete. Steel fibers would be lower workable as compared with the normal concrete. So this is a comparison between the with and without using fibers in the concrete. Okay, so we'll stop here. Do you have any question for this topic that we have listed? We have listed different types of concretes, the application of different types of concretes, the uh, the advantages and disadvantages, the methods of producing this type of concrete. Do you have any question here?